Okay, we're going to start talking about BECs and UBECs. Now, BEC is a battery eliminating circuit. That is built inside of most of your ESCs. All it is a little separate circuit, pretty much a resistor that lowers the voltage to a voltage that the receiver can handle. So in this particular case, I'm using a small 20 amp aircraft ESC that has a built-in BEC. So this ESC is rated for 2 to 4S lipos. Now 3S and 4S lipos directly going to the receiver would be too much voltage. So the BEC inside of the ESC steps that voltage down to 5 volts, which you can see indicated on the fluke meter. That's how you know that the BEC inside of the ESC is working correctly. It doesn't matter if the voltage is 3S or 4S, it's going to do its job to step that down to 5 volts. Now when you start adding servos and loading up the ESC, you'll see that the voltage starts to drop. In this case, we're using 2 standard size Futaba servos, and you can see that when I operate it, you can see that the voltage on the fluke meter fluctuates, and the more that I operate it and the faster that I operate it, it'll dip. Now when I let go, you'll see that it rises back up to 5.1 volts. Now as you can see, that wasn't a very significant drop, and it didn't reach the 3.5 volt cutoff at which the receiver goes into a brownout. But that's only 2 servos. Now if you're having a model that has a lot more servos, let's say a typical aircraft setup would have 4 servos, 1 servo for each aileron, 1 servo for the elevator, and 1 servo for the rudder. Now depending on what size servos those are, it's going to dictate how much amp draw and how much voltage drop that will occur into the receiver. So the more servos that you add, the more work it becomes for the BEC inside of the ESC. On top of that, operating and controlling the motor. So in some of our more heavy, larger setups, especially like a Warbird, where you would have 1 servo for each aileron, 1 servo for the elevator, 1 servo for the rudder, and you might also have 1 servo for each flap and retractable landing gear. Now you are having potentially 6 servos operating, as well as tricycle landing gear would be 3 servos powering the landing gear. So that's 9 items that are potentially drawing power away from the BEC inside of the ESC. That's creating a lot more work and a lot more heat inside of the ESC. If for some reason that BEC inside of the ESC will fail, you will lose power to your receiver, and you will lose your model for lack of signal. So that's when a BEC, or excuse me, a universal BEC, such as this one, will come into play. What this does is it takes away the load from the ESC, and it also gives you backup power. So it is possible to lose your motor and have the ESC have a problem, but still be able to have servo control of your model, and you can potentially dead stick it in and save your model. That's why UBECs are so important. Me personally, anytime I have a model that has flaps and retracts, I always add a BEC. If I have just flaps as well as the other servos for the main flight control servos, I kind of play it by ear on what ESC that I have inside of it. When it comes to some of the cheaper ESCs like this one that I'm using right now, they tend to be a little exaggerated on their amp handling ability, and when you start pushing that higher is when you can run into a potential problem. It is possible to lose the BEC inside of the ESC, but still have a functional ESC. And what I mean by that is you can think that your ESC is actually dead because when you power it up into the receiver, it may not power on the receiver. That doesn't mean that the ESC itself is dead. It could be potentially that just the BEC is dead.